Alright, this was a test on systems and matrices, and we are going to go through the solutions. So problem number one, little linear programming happening here. We want to find the minimum value of this objective function under with this feasible region. So of course what we are going to do is we're going to take these points one at a time and put them in the function. So if I do, for example, 0, 0, all right, that's going to be 2 times 0 minus 0, which is 0. If I do 0, 10, then that's 2 times 0 minus 10, and that's negative 10. All right, if I do 20, 20, then I have 2 times 20 minus 20. So that's 40 minus 20, so that's 20. All right, if I do 45, 15. That's going to be 2 times 45 minus 15. All right, that's going to be 90 minus 15, 75. And if I do 40, 0, all right, that would be 2 times 40 minus 0, so that is 80. And that's it. And that brings me back around to 0, 0. So obviously the lowest value here is negative 10. That's why because we're supposed to find the minimum value. So the minimum value is negative 10. And that is all there is to that. All right, let's see what's next. Which ordered pair is a solution to the system? Now I could actually substitute these values in for x and y and see if I get 2 and see if I get 3 and find the answer that way. This seems like such an easy problem to solve that I think I'm just going to go ahead and just do it righteously because the elimination method involves having opposites that cancel, but these are already opposites. So if I just combine like terms now, okay, I think I'll put it over here. 4x and x, that makes 5x equals 5, okay, because 2 plus 3. And then if I divide both sides by 5 like this, then that's going to give me x equals 1. Okay, so x equals 1. So that narrows it down to either A or B right there. So now I just need to find the y value that goes with it. Maybe I'll do that over here. I'll use the top equation. So I have 4x plus y equals 2. So this becomes 4 times 1 plus y equals 2. Alright, obviously 4 times 1 is just 4. So basically when I subtract 4 from both sides, I get y equals negative 2. Okay, so what we have here is 1, negative 2. That's why the correct answer is B. Alright, for the next one, we are supposed to decide which of the following systems of inequalities represents the given graph. Alright, we've got all these systems here. So let's take a close look at the graph. To me, the easiest thing to do is figure out the equations of these lines. So let's take this line right here, for example. Alright, I see that the y-intercept, what are we counting by 2's? Alright, that makes it a little tricky. Ah, man, I hope that did not mess up my kids. I really don't like that. We're counting by 2's. Okay, so this is 2, 4. Okay, so this y-intercept is -4. And then the slope, and I will use the squares to kind of see the slope. This is going down 2 over 1. Okay, so that's a rise and run. So the slope of this line, okay, so I'm looking at y equals, so this is like -2 over 1, which is just -2. So I'm looking at -2x minus 4. I'm going to be really mad if there's some -2x minus 2's. Come on, people. Seriously? We're going to be that tricky? Alright, that really, I'm not happy with this problem. Anyway, so the equation of this line would be y equals -2x minus 4. Okay, notice it's not -2 because they're counting by 2's. You can tell by the numbers here. So I hope no one got it wrong just because they thought it was a -2 because they were looking at the squares. Me, I think that's a little tricky, and I would not have picked this problem if it were up to me. Anyway, we now need to deal with the fact that this is an inequality. So looking at the shading, I'm hoping you can see that we are staying above this line with the shading. Okay, so it's going to be some sort of a greater than situation. Also, it's a solid line, so specifically we're talking about greater than or equal to. So we should have y is greater than or equal to -2x minus 4. Okay, so far, let's see, that, so here's a possibility. Okay, y is, alright, wanted yellow. Y is greater than or equal to -2x minus 4. Okay, that really looks like the only one. Okay, so I'm thinking the answer is going to be A. But let's follow through and look at the other inequality. So let's see, I think I'll switch to blue. So looking at this one now, the y-intercept here is -2. Again, it's not -1. We're counting by 2's, which I do not like. So keep that in mind. Now the slope, I'm looking at the rise and the run. So when we talk rise over run, I'm going to go ahead and count the squares for that because it doesn't matter. It's like up 1 and over 2, so that's 1/2. So as an equation, I'm looking at y equals positive 1/2 x minus 2. All right, there's that y-intercept we talked about. Okay, now again, we are staying above this line, above, above, above. So we're looking for some type of a greater than happening. Okay, so it's either going to be greater than or greater than or equal to. But we notice that it's a broken line, so that means it's not or equal to. It's strictly greater than. So this should be the other equation. So hopefully when I look back at the answers, I'll see y is greater than 1/2 x minus 2. Y is greater than 1/2 x minus 2. Boom, there you go. Okay, so that's why the answer is in fact A. Alright, what's next? Alright, we got the matrices, and we're doing some calculations. So, for number 4, we're supposed to do -3 times C. Okay, so here's matrix C. So all we're really doing is we're multiplying each one of these numbers by -3. Okay, so of course that's going to give us -3 and 0 and -6 and -6 again and +9 and 0 and -6 again and +12 and -6 again. There's a lot of 2's in there. Okay, I just multiplied everything by -3. So this should be the matrix that you get when you multiply that stuff. Okay, let me see if I can get it over here where it belongs. Alright, so that is your answer to number 4. Okay, what about number 5? For number 5, we're supposed to do B minus D. Alright, keep in mind that it's only possible if the dimensions are exactly the same. And they are exactly the same, so we should be able to do this. Alright, so fine. So B minus D should be another 2 by 3 matrix. And we'll just subtract element minus element. Okay, so 6 minus 2 is 4. -4 minus 1 is -5. Okay, 2 minus 1 is 1. Now be careful on this one. -3 minus -3 is 0. Alright, let me show you that again. I said -3, okay, minus -3. See the double negative here? Alright, this is the same as -3 plus 3. That's why it's 0. And -1 minus 4 is -5. And 5 minus -2 is 7. Okay, again, it's that whole minus and negative thing. So I said we had 5 and then -2, so we have to do 5 minus -2. That's the same thing as 5 plus 2, that's why it's 7. So this would be your answer number 5. Okay, what about A times B? Alright, well first we have to make sure that it can be done. So A is a 2 by 2 matrix. Alright, and then B is a 2 by 3 matrix. Alright, for this to be possible at all, the inner dimensions have to be the same. Okay, so we have 2 and 2, so it is possible. And it's good to note also, like once you decide that it's possible, your answer is going to have the shape of the outer dimensions. Okay, so the product should be a 2 by 3 matrix in the end. Alright, that's useful. So I'm going to set up a 2 by 3 matrix ready to go. Okay, so it's going to be a 2 by 3 matrix. Now, just to make a point, let me say to you, as we set up our 2 by 3 matrix, I like to label all the entries like this. Alright, I'll have element 1, 1, element 1, 2, element 1, 3. Alright, this stands for row 1, column 1, row 1, column 2, row 1, column 3. That makes these element 2, 1, element 2, 2, and element 2, 3. Alright, we need to find these 6 elements. So, how do we do that? Okay, so we're doing A times B. So if I want to do, for example, element 1, 1. Alright, I think I'm going to go a little thinner with my ink here. Element 1, 1, that means row 1 times column 1. sort of like this. Okay, if I do, I'm talking about row 1 of the first matrix and then column 1 of the second matrix. So row 1, column 1, so that's row 1 is 5, 3. Okay, and then column 1 is 6 and negative 3. Okay, now I'm going to multiply that out. So that's going to give me 30 and negative 9. So if I add those up, okay, you know what? Why am I changing my methodology? Okay, I just like to put these in parentheses. Makes me feel better. Okay, so I've got 30 and I've got negative 9, so that's going to be 21. Okay, so element 1, 1 is 21. So I can go ahead and put that down. Alright, let's find another one. Alright, so let's go ahead and find element 1, 2. Alright, element 1, 2, that's row 1 times column 2. So row 1 is again 5, 3. Okay, now this time column 2. So I'm talking about this guy. So that's going to be negative 4, negative 1. And we multiply. So that's going to give me negative 20 and negative 3. So that is negative 23. Alright, so that's element 1, 2 is negative 23. Okay, let's find the next one. So let's go ahead and find element 1, 3. Alright, that's first row, third column. So first row and third column. Okay, so that's going to look like this. So 5, 3 again, and 2, 5. And we will just multiply these together. So that's going to give me 10 and 15, which is 25. Okay, so that's element 1, 3 is 25. Alright, so we just got to do that 3 more times. So let's go ahead and find element 2, 1. Okay, so element 2, 1. So that is the second row, first column. Okay, so second row, first column. Alright, so we're doing these. So that's going to be 6, 1 and 6, negative 3. So that's going to give me 36 and negative 3, which is 33. Okay, so that's the next element, 33. Let's find element 2, 2. Okay, element 2, 2. That's second row, second column. Okay, so again, the second row I already know is going to be 6, 1. Alright, just like it was last time, we're still in the second row. But this time it's the second column, so that's going to wind up being negative 4, negative 1. Alright, I'm sort of copying off of other parts, but row 2, column 2. So there's row 2 and column 2. Okay, so 6, 1, negative 4, negative 1. 6, 1, negative 4, negative 1. Okay, so that's going to make negative 24 and negative 1. So that is negative 25. So that is the next element, negative 25. Okay, now the last element, element 2, 3. Okay, again, it's a row 2 has been the same for the last two problems, so I know that's going to be 6, 1. If I want to see column 3, I can just look here and see column 3 was 2, 5. Kind of copy off myself a little bit. Okay, but we're talking about row 2, column 3, so I could always look back here like I did the other times and talk about row 2 and then column 3. So 6, 1, 2, 5. Okay, but I already knew that. 6, 1, 2, 5. Okay, so that's going to give me 12 and 5, which is 17. So that is the final element. Okay, so that would be the answer to number 6, this matrix right here. All right, I guess I was supposed to be putting these answers down here on this line. Maybe I'll pretty that up later, but for now, let's see if we can find number 7. Oh, next page. All right, it says find the determinant of the following matrices. Well, for a 2 by 2 matrix, the determinant is as simple as down diagonal minus the up diagonal. It's as simple as that. Okay, so that means we're just going to do the down diagonal, which is negative 18, minus the up diagonal, which is also negative 18. All right, well that's negative 18 plus 18, which is 0. Okay, so the determinant of matrix D is 0. Good to know. Okay, now we'll do the same thing for matrix E over here. All right, again, the determinant of a 2 by 2 matrix is just the down diagonal minus the up diagonal. Okay, so the down diagonal is 20 minus the up diagonal, which is 18, means that the determinant is 2. Okay, all right, maybe I should put these on the line. So we had 0 and we had 2. Okay, what else we got? All right, number 9 and 10. Okay, notice that number 9 is the same matrix as number 7. Okay, and notice that number 10 is the same matrix as number 8. So that should save us a little bit of work. All right, because the first step of finding the inverse is to find the determinant. Now, since the determinant is 0, then there will be no inverse for number 9. Answer should be written as reduced fractions. Okay, so for number 9, we're just going to say does not, you know what, I'm just going to say undefined. All right, I could have said does not exist. Okay, undefined. All right, now for E, hold on. For E, once you have the determinant there, the first thing you do for the inverse, which I would write this way, like E minus 1, would be the reciprocal of this. So I'm going to put 1 over 2. That just means I'm going to divide by 2 later. Haha, I get to say it again. This is where we reverse negate. Cha-cha slide. So this is going to be, when I say reverse negate, barely because I'm losing my voice, you reverse the down diagonal and you negate the up diagonal. Okay, so reversing the down diagonal means switching these. So that's why I'm going to have -10 and -2. Now, negating the up diagonal means changing the signs of these. So that'll be -2 and this will be -9. For the final answer, I need to divide everything by 2. Alright, thus the 1/2. So that's why the final answer will be -5, -9 over 2, -1, and -1. Okay, that is the inverse. Alright, so that was 9 and 10. Let's see what's up with 11. Which of the above matrices does not have an inverse? Well, okay, this is kind of a silly question because since they just asked us to find the inverse, we already saw that number 9 didn't have an inverse. So it's kind of the same question twice to me, except for maybe the explanation. So obviously, matrix D does not have an inverse, and the reason was because the determinant was 0. Yeah, like I said, matrix D has no inverse because the determinant is 0. Okay, moving on. In general, for two matrices, A and B, does A times B equal B times A? Why or why not? Explain. Well, yeah, the answer to that is definitely no. Okay, no, A times B does not equal B times A. And the easiest thing to do is to give an example. For example, let's say that matrix A is a 2 by 3 matrix. Okay, and we want to multiply that times matrix B, and let's say that that is a 3 by 2 matrix. Alright, that would be doable because the inner dimensions are the same, and the product AB would have dimensions 2 by 2, the outer dimensions. So AB would be a 2 by 2 matrix. Okay. On the other hand, okay, if I wanted to do matrix B times matrix A, all right, we already decided matrix B was a 3 by 2 matrix, so we can't change it now. So matrix B is a 3 by 2 matrix. We already said that matrix A was a 2 by 3 matrix. Alright, it would still be doable because the inner dimensions are still the same. However, the product BA would have dimensions 3 by 3. Okay, so AB is a 2 by 2 matrix and a BA is a 3 by 3 matrix. So without knowing the details of what the elements of the matrices are, they're not even the same shape. Alright, so there's no way they can be equal. Alright, so I'll just put an extra sentence down here to that effect. So in this example, AB is a 2 by 2 matrix, while BA is a 3 by 3 matrix. They are not equal. Alright, it's time for me to go serve my lunch duty patrol the pavilion. But I'll be back to work on some more of this video after that. You won't even miss me. You won't even know I was gone. To you, it'll be like that. Alright, so we're supposed to draw a vertex edge graph to represent the portion of the United States shown here. The vertices are going to represent states, and the edges are going to represent the borders, a shared border between the states. Okay, so Colorado. I'll let Colorado be C. And Nebraska can be N. Alright. Iowa can be I. Maybe I should spread this out a little bit more. Oh, you know what? I really do not like it when it does that. Let me try this again. Okay, where was I? Alright, that's right. Missouri and Kansas. Alright, just like to spread them out. Now, Colorado shares a border with Nebraska and Kansas. Okay. So there's the Nebraska connection, and there's the Kansas connection. Now, Nebraska shares a border with, of course, Colorado, but also, well, dadgum, Nebraska shares a border with every single state in this very small union. So, kabam, 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 and what? Kabam. Alright, Nebraska is just reaching out and touching everybody. Now, Iowa shares a border with Nebraska, of course, and Missouri, but that's it. Pow pow. So there's Nebraska, there's Missouri. Okay, Missouri shares a border with Iowa, Nebraska, and Kansas. Brat. So there's Iowa, there's Nebraska, there's Kansas. Kansas shares a border with Colorado, Nebraska, and Montana. There's Colorado, Nebraska, and there's Montana. So there would be a nice vertex edge graph representing the situation of shared borders. Okay, so far so good. Alright, let's see. Number 14. Create a matrix that represents this. Alright, I guess I'll have to back this out just a little bit. Alright, gotta make more space. Okay, so you're even given the hint that you know, it's on. So all of the letters are represented across the top and down the side. So this is a 5x5 matrix, if you will. And you know what? It makes me feel better if I draw the lines, so I'm going to do that. I went ahead and copied the vertex edge graph down here just so I wouldn't have to scroll back and forth. Anyway, now it's time to put in the numbers reflecting connections, shared borders between these states. Since you cannot share a border with yourself, this diagonal will be all zeros, reflecting that, you know what, it's been like a day, and I don't remember, so that's, yeah, Nebraska. Yeah, so for example, Nebraska cannot share a border with itself, so zeros down the diagonal. Let's see, so we got Colorado, Nebraska, Iowa, Missouri, Kansas. Yeah, so Colorado is connected with Nebraska and Kansas. So boom, boom. All right, Nebraska and Kansas. It is not connected with any of the other states. No borders. So that's going to be 0, 0, 0, 0. Okay. Nebraska is connected to all 4 of the other states. So Nebraska, let's go. Okay. Duplicate. Iowa is connected with Nebraska and Missouri. Okay, so there's Nebraska, here's Missouri, but not Kansas. Okay, so from this direction, Iowa is connected with Missouri, Nebraska and Missouri, but not Kansas. And finally, Missouri is connected with Kansas, Nebraska, and Iowa. So Missouri is connected to Kansas, and there's Nebraska and Iowa. Okay, but that'll be duplicated here. Missouri is connected with Kansas. Okay, so this is the matrix version of with the same information as this vertex edge graph. So now we are supposed to explain what the elements in the matrix S to the 5th power would represent. If we did this to the 5th power, just understand that this original matrix is really showing the number of ways that you can get from one state to another crossing one border. So this 0 here shows that there are 0 ways to get from Colorado to Iowa while crossing one border. If we squared this, it would show how many ways to get from state to state crossing 2 borders. Alright, squaring it would mean you're crossing 2 borders. If we cubed it, it would be showing how many ways to get from one state to another crossing 3 borders. Alright, so if we're doing the 5th power, it's showing how many ways there are to get from one state to another crossing 5 borders. Okay, so you just need to write that down. Bam, like that. Okay, let's move on. Hello, darling.
Can I use your phone?
For what would you like to use my phone?
I need, well, I actually need you to check your email on your phone.
Why?
Because, I put on the upstairs computer my Club Penguin information, but I could not find it. I'm pretty sure that's because it was on my account, and we deleted that because we used yours. So I had to make a new one.
Alright, let me pause the video. Club Penguin indeed. Alright, so we're supposed to graph the triangle with the given vertices, blah blah blah. The graph is really irrelevant. I mean, I can go ahead and do it. Alright, there, I graphed it. In order to find the area of a triangle by using the vertices, I mean, it tells you to do determinant. This is how you do it. You set up a 3x3 matrix using the vertices like so. -2, 5, 4, 3, 1, negative 5. We will do the third column with ones. 1, 1, 1. Like it says, we're going to use the determinant, so we'll go ahead and set that up. I'm using straight lines because that means take the determinant. Part of the formula is a plus or minus 1/2 that goes in the front. And really the point of the plus or minus is area must be positive. So no matter what happens, we have to make sure that the area is positive. So if it turns out to be negative, this plus or minus tells us to switch it to a positive. Then you need to recopy the first two columns like this: negative 2, 5, 4, 3, 1, negative 5. This is just how you do the determinant. So the way you do the determinant of a 3 by 3 matrix, you do the down diagonals minus the up diagonals. These are the down diagonals. So what we have here is plus or minus 1/2, and now we're going to do the down diagonals minus the up diagonals. Yeah. The down diagonals are negative 6, 5, and negative 20. Okay. The up diagonals are these. Okay, so the up diagonals are 3, 10, and 20. Whoops, positive 20. All right. I'm going to put this part in my handy-dandy calculator. So we have negative 6 plus 5 minus 20 minus 3 plus 10 plus 20. That is negative 54. Okay, so we have plus or minus 1/2 of negative 54. Half of 54 is 27. Okay, so of course we want the area to be positive, so we'll choose positive 27. So that is how you do it. Alright, the answer number 15 is 27. Let us move on to number 16. Define the variable, set up a system of equations, and solve the system using matrices. The drama club is selling tickets to a play. The children's tickets cost $5 each, and the adult tickets cost $8 each. A total of 561 tickets were sold, and $3,708 was raised. How many of each ticket were sold? Okay, so we need some variables. It sounds like we have children's tickets and adult tickets. So you could use X and Y if you want. I'm going to use C and A. So I'm going to let C equal the number, because it says how many. So I'm going to let C equal the number of child tickets. And I'm going to let A be the number of adult tickets. Okay. Well, there's one equation that's hiding within this number right here, 561. Total of 561 tickets. Look, some of the tickets were child tickets, some were adult tickets, but the total is 561. That immediately suggests the equation C plus A should equal 561. We got some of these and we got some of these. The total has to be 561. All right. Then the other equation is the money equation. Okay. We've got, oh, that's the highlighter. We've got $5 for each child ticket, $8 for each adult ticket, total of $3,708. Money, money, money. Even if you're only guessing, it should make sense to you that the money should all go in one equation. Okay, so like I said, $5 per child ticket plus $8 per adult ticket, total of $3,708. So these are the equations. This is the system. So we've set it up, and now we're supposed to solve this using matrices. So this is going to become, all right, I mean, considering that the coefficients are 1 and 1 for those two, my coefficient matrix is going to be 1, 1, 5, 8. Okay, there's my coefficient matrix. And I'll have a variable matrix, CA. All right, it has to be in order. All right, and that should equal my constant matrix, which is 561 and 3,708. Okay, so this next part is not optional. You must have it for full credit. Let's to save us some work later, let's label these matrices. So this is matrix A, X, and B. All right. Now that we've labeled those matrices, we can say this: A times X equals B. All right. That's what we have here. A times X equals B. But whenever that is true, then it's also true that matrix X will equal A inverse times B. So everything that I just wrote in red, you must write down. This is part of showing your work. Okay, so we're trying to find X, and to find X, that's A inverse times B. Well, we have B. What we need is A inverse. So off to the side somewhere, I'm going to go find A inverse. Okay, I think I will use purple. Okay, so over here, I am going to find A inverse. Well, the first step to finding A inverse is we need the determinant. So first we need the determinant of A. Okay, so the determinant is just the down diagonal minus the up diagonal. So that's going to be 8 minus 5, which is 3. So that is the determinant. All right, now with that in mind, then A inverse is going to equal 1/3. All right, it's the reciprocal of the determinant, times, and here's where we do our reverse negate. We're going to reverse the down diagonal and negate the up diagonal. Okay, so I'm reversing this. So that's going to give me 8 and 1. And then I am negating this, which means just changing the signs. So that's going to give me -5 and -1. Okay, I reversed and I negated. So this is the inverse. Now normally we would take this 3 and divide everything by 3 and make a bunch of fractions. But I say we save that step for later to keep our calculations easier. So for right now, we'll leave our inverse in this form, 1/3 times this matrix. Now, so we can get back to work. We're supposed to do A inverse times B. So let's do that. Okay, so we decided that x would equal A inverse times B. And now we know that A inverse is 1/3. Okay, 8, -1, -5, 1. Right, so that's A inverse. And then there's B. Okay, and so that is 561 and 3708. Alright, so we just said x would equal A inverse times B, and now here we have it. This is A inverse, and this is B. So we're doing A inverse times B. Now the easiest way to do A inverse times B is to multiply these two matrices together first, and then divide everything by 3 at the very end. So let's do that. Well, this is a 2 by 2 matrix, and this is a 2 by 1 matrix. So it's possible to multiply looking at the inner dimensions, and the outer dimensions, 2 and 1, tell us that the final answer is going to be in the form 2 by 1. Okay, so our final answer is going to be like this. For now, that 1/3 is still going to be there, but I know I'm going to have a 2 by 1 matrix, and I will represent it this way: element 1, 1, and element 2, 1. Okay, so our answer is going to be in this form. Alright, this is a 2 by 1. Okay, so what we need to do is find element 1, 1 and find element 2, 1. So let's do that. Okay, well, element 1, 1. Element 1, 1 is row 1 times column 1. So I'm talking about row 1 times column 1. So when we do that, row 1 is our 8, -1, and our column 1 is 561 and 3708. So we need to multiply these because we're doing row 1 times column 1. Alright, 4,488. Alright, and -3,708. Okay, and then we'll add these together, and that will give us element 1, 1. Okay, I can just go minus 3,708, and it remembers the last number was this. So I'm getting 780. Okay, so that is element 1, 1. Okay, is there room for me to squeeze this in over here? Yeah, maybe I'll just put it underneath. Okay, so that is going to give me 1/3, and so far I have 780. Okay, now I need element 2, 1. Alright, that's fine and dandy. Okay, I think I'll use green again. Element 2, 1. Well, that is row 2 times column 1. Like this and this. So that is going to be -5, 1. Okay, that's row 2. And then 561, 3,708. So this is row 2 times column 1. Okay, I'm starting to regret putting this here. Yeah, so negative 5 times 561 is negative 2,805. And then 1 times 3,708 is what it is. So we'll put these together, and then there you have it. So I'll just go plus 3,708. So that's 903. Okay, so that should be my second element. Alright, which I could put right there. Okay, so all I have to do now is divide both of these by 3 to deal with that 1/3, and then that should be my final answer. Alright, so we get 260. You can probably guess what this one's going to be. And you guessed it. So those are the two answers that we are dealing with. 260 and 301. Well, I did not mean to put the 1/3 again. We just divided by 3, so no more 1/3. So this is the final answer. Okay, what we have found is matrix X. Okay, so that means, all right, just to follow all the way through, remember that matrix X was this matrix, C and A. Okay, so that means that C is 260, all right, the number of child tickets, and A is 301, the number of adult tickets. So before we call ourselves completely finished, we should take this and put it into a sentence. They sold 260 child tickets and 301 adult tickets. And that's how you wrap up a word problem. Alright, so that was it for number 16. Let's move on to number 17. Alright, we're supposed to create matrix B such that A times B is possible, but A plus B is not possible. Okay, let's take it one piece at a time. So we're just trying to think of matrix B. Well, we know that matrix A is a 2 by 2 matrix. Okay, so this matrix B, whatever it is, I'm just going to put a little outline of it. Okay, so say if this is matrix B, if A times B is going to be possible, alright, then the inner dimensions would have to be the same. So I know right now that this has got to be 2 by something. Alright, so it has to be a 2 by something matrix. Now, we want A plus B to not be possible. Alright, so in order to be able to add A plus B, the dimensions would have to be exactly the same. So I would need a 2 by 2 matrix. So it sounds like if I do 2 by anything else, it will fit the criteria. So for example, I could just make this a 2 by 3 matrix. Or it could have been a 2 by 4 or 2 by 5. Alright, anything other than a 2 by 2. It had to be 2 by something. So this would work because A times B is possible because the inner dimensions are the same, but A plus B is not possible because all of the dimensions are not the same. All right, you can only add a 2 by 2 matrix with another 2 by 2 matrix. Okay, so all I need now is to make up some kind of a 2 by 3 matrix. So I will just make one up, and I will go with 1, 2, 3, 4, 5, 6. All right, not very creative, I know, but that would be one answer. So I'm just going to make a note to myself when I'm grading papers later that whatever your answer is, it needs to be, it has to be 2 by something, but not 2 by 2. Okay, so for example, it could be a 2 by 3, or it could be 2 by 4, or it could be 2 by 5. All right, I doubt. Oh, you know, it could even be 2 by 1. Okay, all of these would be okay. I doubt I'm going to look at somebody's paper and see a 2 by 6 or higher. So I'll be looking for these when I grade your papers. Okay. Just a note to myself. Let me write many answers. There are many answers possible. All right, moving on to number 18. Choose values for A, B, and C so that this system will have infinitely many solutions. Well, let me remind you of how infinitely many solutions happen. You might remember that if all the variables cancel out and you get 0 equals 0, or really anything equal to itself, could be 5 equals 5, but it's usually 0 equals 0. This is, when this happens, you know that you've got infinitely many solutions. Infinitely many solutions. Okay, on the other hand, we've learned that if all the variables cancel out and you get a false statement, like 0 equals 5, or something like that, 0 equals 21, anything like that, where it's not true, this is a signal to you that it is no solution. Okay, for a system like that. So a lot of you have that in your brain somewhere, but you kind of forget how this happens. So let me remind you. If I want infinitely many, so I'm looking for the 0 equals 0 type of an option. Here's a quick example of how that could go down. Say if the first equation was 5x plus, you know, let me throw a negative in here just for fun. 5x minus 3y is equal to 14. Okay. Then if the next equation turned out to be negative 5x plus 3y is equal to negative 14. All right, you know, I'm thinking of the elimination method. If at any point we saw these two equations as we were trying to make opposites that cancel, but what would happen is these would cancel and these would cancel, which would give me 0, but also these would cancel, which would give me another 0. So that's when you get your 0 equals 0, and that would be infinitely many. So that's the type of thing that we're shooting for. All right, this is what you should be picturing in your mind when you look at this problem. Okay, but all right, instead of that system, what we have is, okay, I'll just sort of recopy this. We've got x plus y is equal to 2. All right, now down here we have ax, all right, plus by is equal to c. And you're being asked to choose values for A, B, and C that will make this infinitely many solutions. So what you need is an A, B, and a C that will cancel everything out and cause it to be 0 equals 0, like I just showed you. Alright, well, this is a positive x, like a positive 1x, if you will. So if you want to cancel that out, what you need is a negative x. Alright, now since we're looking for A, B, and C, I will call it a negative 1x. Alright, because that's a positive 1x. What you need here, instead of B, is again a negative 1. Alright, a negative 1y to cancel out the positive y above. And what you need here instead of C is a negative 2. Because we want 0 equals 0. So we really need to cancel out the negative 2 as well. Alright, so if C is negative 2, that will cancel out the positive 2. Alright, and if you had that, then sure enough, the x's would cancel, the y's would cancel, and even the 2's would cancel, and we'd get 0 equals 0. Which is why the final answer is A equals negative 1, B equals negative 1, and C equals negative 2. Those are the values that we would need to cancel everything out, get 0 equals 0, meaning infinitely many solutions. Now, I could just as easily have asked you what do A, B, and C need to be in order to be no solution. For that, the A and B would still have to cancel out, so they would still be negative 1. But the C would need to be anything other than negative 2. Alright, just so those wouldn't cancel out, and then you'd have 0 equals some number, and that would be no solution. Alright, just keep that in the back of your mind. Let's move on to number 19. Alright, we're going to solve another matrix equation. Now this is going to be similar to when we did this word problem up here. And we made the system ourselves, but then we had to do this whole A times X equals B business. And we're going to have to do that again for this problem. Alright, but this time they give us the system of equations. And there are 3 of them. Okay, so here we go. So scanning across here, as I make my matrix equation, I see negative 5, 3, 6, negative 3, 1, 5, negative 2, 4, 1. This will be my coefficient matrix. Okay. Then comes the variable matrix, which is just X, Y, and Z. And that will equal the constant matrix, which is 4, negative 5, and 13. Alright, this is our matrix equation. We must label it. This is part of showing your work. This is matrix A, this is matrix X, and this is matrix B. Okay, you must also write this down. Alright, we labeled it so this could follow. What we have here is A times X equals B, so just write that down. If A times X equals B, then X equals A inverse times B. Alright, I'm saving you a lot of work by allowing you to simply label the matrices and then show your work symbolically. Okay, but you don't get to skip it just because it's so easy. You can't just leave it out. This has to be there. Okay, so we need to go about the business of doing A inverse times B. Well, A inverse, luckily we're given A inverse. Okay, inverse coefficient matrix. Boom. So they're telling us, and we must label this is A inverse. So we're supposed to do A inverse times B. So that means we need to do this times B. Okay, so fine. 4, -5, 13. Okay, so that, my friends, is B. Alright, so now we have A inverse times B, and X should equal all this. In fact, I think I will just cover this up. Alright, and replace it with my own X equals A inverse times B. Alright, so all we have to do is carry out this multiplication, and that should give us our variable matrix X. Alright, I think there's enough room over here. Of course, this is a 3 by 3 matrix. And B is a 3 by 1 matrix. So that means the final answer should be a 3 by 1 matrix as well. So it's good to set that up. Okay, so this is going to be matrix X when it's done. But this will be element 1, 1, element, whoops. Alright, this will be element 2, 1. Alright, because this is row 2, column 1. And this will be element 3, 1, row 3, column 1. So we just need to find these 3 elements, and then we're home free. Okay, let me see if I can squeeze that in right here. So let's start with element 1, 1. Okay, so element 1, 1. That means row 1 times column 1. So I'm doing row 1, it's a very thick row, times column 1. Alright, so that would look like this. I've got negative 19 over 14 and 3 over 2 and 9 over 14. Okay, and then we've got 4, -5, and 13. And we are supposed to multiply these. So we're going to multiply row by column. Okay, so that means I need to do 4 times 19. I really just multiply the numerator here because it's 4 over 1. And you know what? I don't know that off the top of my head. Okay, 76. Okay, so that means I have negative 76 over 14. And then -5 times 3, so that's going to be negative 15 over 2. And 13 times 9, which is 117 over 14. Okay, so now we just have to add all these up and get the final result. I'm just going to scroll down a little bit. Okay, if I add all these up, and I will use my calculator to help me do that. Okay, so I'm doing negative 76 over 14 plus negative 15 over 2 plus 117 over 14. And what I get is negative 32 over 7. Okay, so that is my first element. Alright, and I think I'm just going to type that right in here because I'm running out of space. Okay, so I'm just going to replace this with negative 32 over 7. Okay, so that is the first element. Now let's find, or you know, I guess I could have written it right here. Negative 32 over 7. Okay. Guess I can leave that the way it was. Alright, now all we have to do is do that a couple more times. So now let's find element 2, 1. Okay, so here we go. Element 2, 1. That's row 2, column 1. Alright, so there's row 2. So what I'm going to have is negative 1/2, 1/2, and 1/2. And then the same old column 1 here. I've got 4, negative 5, and 13. I'm supposed to multiply these together. Okay, so that's going to give me negative 2 and negative 5 over 2 and 13 over 2. I'm supposed to add all these together. Can we move over at all? No. Okay. So I've got negative 2, negative 5 over 2, (13 over 2). So that gives me 2. Alright. So I've got negative 32 over 7, and I've got 2 so far. Alright, one more to go. Let's go. So let's find element 3, 1. Alright, I'm running out of space. I'm going to squeeze it in right here. Okay, let's go. So element 3, 1. So that's row 3 times column 1. I've got space. Alright, row 3 times column 1. So row 3 is this. So negative 5 over 7, 1, and 2 over 7. Alright, let me just double check that. Oh, it's not negative. Negative 5 over 7, 1, and positive 2 over 7. Okay, my memory is weak, my friends. Weak memory burden. And then, as you can see, the other, the column is the same for all of these. So I'm just going to copy it off of here. So that's 4, negative 5, and 13. And we are going to multiply these together like we do. Okay, so that is going to give me, alright, you know, I feel like I do need a little bit of space. Just move over. Alright, that is going to give me negative 20 over 7 and negative 5 and 26 over 7. Okay, because I'm just multiplying the numerator by these guys. Just the numerator. Alright, so one more time I need to add all these up so I can call it a day. I turn to my handy dandy calculator. Situations like this. Whoa, too big calculator. You know what, I'll just do that. Okay, so negative 20 over 7. Negative 5. 26 over 7. That's negative 29 over 7. Kabam! Alright, and that is the third and final element. Alright, and that is how you do that, my friends. That is how you do that. And I feel like, bam, 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 we are at the bottom. This is page 4. Alright, I think we're done with this test. Alright, I hope this has been helpful to you, helping you understand the various concepts that we learned throughout this unit. And I will, in fact, see you on the next video.
Have you seen Kayla and Mommy?
No, I have been down here in this basement making this video for my kids at school. Have you seen Kayla and Mommy?
No. I'm looking for Kayla because
Kids watching this video, you can stop watching now because I'm finished with the video. I'm just talking to my kid now. Go away. Turn the video off.
You're funny.
Haha, you're funny looking.
Well, when I try to buy something, I click on it. Like, I don't know how to put it in my inventory.
You're talking about Club Penguin?
Yeah. It's not that, you know, with the membership thing. I remember. And
Come closer so I can hear you.
it's just that I don't know how to get it in my inventory. Although I can afford it, but it's
Have you been eating peanut butter?
yeah, just one spoon. It's not anything to do with the membership. It's just that I can't.
You just don't know how to use the software fully.
Yeah, because I can afford it with my Club Penguin money, but we'll get into my inventory.
Alright, Kayla's probably in her room. Did you try looking there?
Yep. And I don't see Mom either, so I'm pretty sure she'll.
Turning off the video now. See you on the next video.